In this video, I'm going to talk about radical equation of surds, and I'll be teaching you how to solve problems with examples. For the most basic radical equation that you can find, AS plus B squared is equal to C. So before we get into example, I want to know some terms. This equation given like this thing as a whole, this whole square root term, everything inside the square root and the square root itself is called a radical. Everything inside the square root of the radical is called a radicand. And then the roots of the radical is called roots. So the roots could be square root, cube roots, fourth roots, fifth roots, sixth roots, or something like that. These are the terms that are associated with radicals. So let's quickly get into problem solving so that you understand radical equations more. So for our first example, we have square root of 5 minus x and then minus 3. So when you are given a radical equation like this, the first step is to isolate the radical. So this is the radical and we have to isolate it. So to isolate it, I have square root of 5 minus x minus 3. This is the original question. So to isolate this radical, I'll be moving minus 3 over to the other side of the equation. So I'll have square root of 5 minus x. This is equal to minus 3 crossing over to this other side is 3. So the next step, once you've isolated your radical, is to take the square of both sides. I'm taking the square of both sides because I have a square root here. If I had a third root here, I'll be taking the cube of both sides. So this is square of this side and this is square of this side. So square can cancel out square root. So that I have 5 minus x is equal to 3 square is 9. So making x the subject of formula, I have minus x is equal to, if I'm moving 5 over to this side, this is plus 5, it becomes negative 5. So I have 9 minus 5. So this is minus x is equal to 9 minus 5 is 4. And then I'll be dividing both sides by minus 1 to eliminate this negative here. So I have x is equal to minus 4. So the next step is to plug it back into the equation to see whether your answer is correct. So the original equation is given as square root of 5 minus x, and then this is minus 3 is equal to 0. So square root of 5 minus open bracket minus 4. So I've plugged in the value of x, minus 3 is equal to 0. So this is square root of 5 minus 4 is plus 4. So we have 5 plus 4 minus 3 is equal to 0. So here I have 5 plus 4 is 9. So square root of 9 minus 3. Square root of 9 is 3. So 3 minus 3 is equal to 0. 3 minus 3 is 0 is equal to 0. So this answer of x is equal to minus 4 is our answer to this radical equation. So let's quickly take another example for you to become familiar. For the second example, you can pause the video and try to solve it yourself. Okay, so like we did before, let's write out the equation. We have 4 plus cube root of x minus 6 is equal to 2. So the first step is to isolate the radical. Now this is the radical. I'll be moving 4 over to this side. So I'll be writing the radical down first. So this is cube root of x minus 6 is equal to, this is 2. And then remember we moved 4 over to this side. Now plus 4 becomes minus 4. So that I have the radical isolated now. So this is the cube root of x minus 6 is equal to 2 minus 4 is minus 2. So the next step eliminates the radical. So I'll have to take the cube of both sides to eliminate the radical. The cube root can cancel out the cube. So I'll be left with x minus 6 is equal to minus 2 cube is minus 8. Making x subject the formula for this equation, I have x is equal to minus 6 moving over to this side is plus 6. So this is minus 8 plus 6. So x is equal to minus 2. Now the next step is to check our answer in our solution to make sure this answer is correct. So I have 4 plus cube root of x minus 6 is equal to 2. So this is the original question written out. So this is 4 plus cube root of x is minus 2 minus 6. This is equal to 2. So we know that 4 plus cube root of minus 2 minus 6 is minus 8. And this is equal to 2. So 4 plus cube root of minus 8 is simply minus 2. This is equal to 2. So we have 4 minus 2, and then this is equal to 2. 4 minus 2 is still 2. So 2 is equal to 2. So that means x is the solution to this equation. So for the third question, this one is a bit different from the other ones. So to solve this kind of problem where you have square roots on both sides of the equation, you write out the question first. So this is square root of z minus 6, and then we have plus 3. And this is equal to square root of z plus 9. So the first step to eliminate the radicals. Remember, the whole point of this thing is to eliminate these radicals. Is to take the square of both sides. So if you notice here, this square cannot cancel out the square root here directly. So we have to expand this bracket. For the first bracket, we have square root of z minus 6 plus 3. And then the second bracket of itself is square root of z minus 6 plus 3. This is equal to, in this case, the square can cancel out the square root. So we are left with z plus 9. If I'm multiplying these two brackets together, this is square root of z minus 6 times square root of z minus 6. So this is square root of z minus 6, and then I'll have square over them. Then for the next one, I'm multiplying z minus 6 by 3. So this is plus 3 square root of z minus 6. And then for the next, I'll be doing 3 times z minus 6. So this is plus 3 times z minus 6. And then for the next one, I'll be doing 3 times 3. So this is plus 3 square. This is equal to, for the right hand side, I have z plus 9. So I knew that square root of z minus 6 can cancel out square of this term. So this square can cancel out this. So this is z minus 6 plus, these two terms can add up because they have the same radical term. So this is 3 plus 3. So in the end, I have 6 square root of z minus 6 plus 3 square is 9, and then this is equal to z plus 9. This looks like the first set of equations that we dealt with. So the next step is to still isolate this radical. So to isolate this radical, I'm going to move all variables and constant term over to the right hand side. So first of all, write out my radical. So this is 6 square root of z minus 6. Starting with z here, I'll be moving it over to this side. Before I do that, let me write out these terms. So this is z plus 9. Moving z over to this side, z becomes minus z. Moving minus 6 over to this side, it becomes plus 6. Moving 9 over to this side becomes minus 9. Minus z can cancel out z. 9 can cancel out minus 9. So let me clean up space to continue my analysis. Writing out these terms, I have 6 square root of z minus 6 is equal to, and then the only term left here is 6. So if I need to isolate this radical, I need to remove 6 from the radical itself. So I'll be dividing both sides by 6. So that 6 cancel out 6. So I'll be left with square root of z minus 6. And this is equal to 6 divided by 6 is equal to 1. So this is 1. Now to continue this analysis, I have to take the square of both sides to eliminate this radical. So square of this side, square of this side. So square can cancel out square root. So that will be left z minus 6 is equal to 1. So making z subject to formula in this equation, I have z is equal to minus 6 going over to this side is 1 plus 6. So z is equal to 7. For our last step, like we always do, is check whether our answer is correct. So writing out this equation, I have the square root of z minus 6 plus 3. This is equal to square root of z plus 9. So we know that z is 7. So we're taking square root of z, which is 7 minus 6, plus 3 is equal to square root of z is 7 plus 9. So we have square root of 7 minus 6 is 1. So square root of 1 plus 3 is equal to 7 plus 9 is 16. So square root of 16. So this square root of 1 is 1 plus 3. This is equal to square root of 16 is 4. So 1 plus 3 is 4. And then this is equal to 4. So that means the solution of z is equal to 7 is correct for this equation. Let's move on to the next example. You can try to pause the video and solve this example yourself. Okay, so like we've been doing before, let's write out the question. So we have square root of 2t plus 15. This is equal to t. So to eliminate the radical, like we've always been doing, we need to square both sides. Take the square of here. I'll take the square of here. So the square can cancel out the square root. I'll be left with 2t plus 15 is equal to t squared. Now we can move the constant term and the t term over to this side. So we have 0 is equal to t squared. 2t going over to this side is minus 2t minus 15. We can see we write this equation as t squared minus 2t minus 15 is equal to 0. So we have a quadratic equation on our hands. To solve this quadratic equation, multiply this term and this term. So this is minus 15t squared. So we need to look for two terms that when multiplied together should give us minus 15t squared and should add up to minus 2t. So those two terms are minus 5t and 3t. So I can use these two terms to replace minus 2t here. So this is t squared minus 5t plus 3t minus 15 is equal to 0. So I'm factorizing these two terms in batches. So for the first term, the common factor there is t, open bracket. If I factorize t from t squared, I have t minus. If I factorize t from 5t, I have 5. The common factor for these two terms is 3. So this is plus 3. Factorizing 3 from 3t is t. 3 from minus 15 is minus 5. After factorization, both of your brackets should be equal to each other. So this is t plus 3. And then taking the second bracket of t minus 5 is equal to 0. So the solution to my answers, I can equate each of them to 0 and say t plus 3 is equal to 0. And then t minus 5 is equal to 0. So that t is equal to plus 3 going over to this side is minus 3, comma, t minus 5 going over to this side is t is equal to 5. We've gotten the values of t. We know that t can be minus 3 or 5. But let's plug it back into this equation to make sure that our answers are correct. So the original equation was given as square root of 2t plus 15 is equal to t. So the first solution of when c is equal to minus 3, if you plug it in here, we have square root of 2, open bracket, minus 3 plus 15. Now this is equal to minus 3. So from here I have square root of 2 times minus 3 is minus 6 plus 15. This is equal to minus 3. Minus 6 plus 15 is square root of 9. This is equal to minus 3. So square root of 9 is 3. And then this is equal to minus 3. So this means that t is equal to minus 3 is not a solution to this equation. So we can say t is equal to minus 3 is an extraneous solution. So anytime you substitute your values back into the equation and they don't equal to each other, that particular solution is called an extraneous solution. So that is not a solution to the original equation. So let's check for when C is 5. So when C is equal to 5, we have square root of the question is 2t plus 15 is equal to t. So square root of 2 times 5 plus 15 is equal to 5. So 2 times 5 is 10 plus 15. Now everything here is square root, and then this is 5. So 10 plus 15 is square root of 25. This is equal to 5. So square root of 25 is 5, and then this is equal to 5. So that means that C is equal to 5 is the solution to this our equation, while C is equal to minus 3 is an extraneous solution to this our solution. So the solution to this our equation is simply T is equal to 5. We do not count the extraneous solution. So that's how to solve radical equations of surds. Now if you like this video, leave a thumbs up, share with people who might find it helpful, or with your friends. Make sure to also subscribe, it helps me create more videos. Thanks for watching again.